share the agenda of this session now. In this session, we will cover a brief overview of Unified Modeling Language and UML use case diagrams. Having covered that, we will move on to a case study in which we will prepare a use case diagram through Microsoft Visio. So I am starting this session now. Let us start with what is a model and what are its benefits. Then we will cover what is the beginning of UML. Introduction to Unified Modeling Language. Need of UML. UML notations, diagrams in UML, and concepts of UML. This is all what we will cover. Friends, just give me a minute. I'll check my telephone. Let me see if all the attendees are here. Someone is seeking some help. Just give me a second. So now I am resuming the lecture. Some standard question when we talk about Unified Modeling Language. What is a model? Why should we model? How do we model? What are software models? Why do we need software models? What are general outputs when we model? What is unified? What we will be uncovering all these questions in a matter of minutes shortly. UML is an acronym for Unified Modeling Language. It has now become lingua franca or common language of the IT business analyst profession. So, if you are an IT business analyst, knowledge of UML is very important. Some people may say otherwise, but UML is a formal language and it separates you from the rest. UML is an object management group standard. Current version of UML is 2.4.1. These versions get revised time to time. UML promises easy and superior specification coupled with unambiguous interpretation. Friends, I have taught you how to prepare a requirements document. So there you capture the requirements specification. So UML allows you to do it in an easy and superior manner and unambiguously. UML has got 7 behavior diagrams and 7 structure diagrams. Important UML diagrams for business analysts are use case diagram, interaction diagram, state machine, and activities diagram. I regard activity diagram, use case diagram, and state machine diagram very important for business analysts. A BA should be able to also read class diagrams and be able to prepare basic class diagrams. BA should also know deployment diagrams. Deployment diagrams are structure diagrams which inform us about the location of deployment of our software. Every UML diagram has got a standard notation, visual symbol or sign, and a standard terminology. A BA must clearly remember notation and terminology of individual UML diagram. there should not be any ambiguity in the use of related term. To make a point, the UML superstructure document version 2.4.1 has the terminology of activities. So it does not talk about flowchart, it does not talk about activity diagram, it does not talk about activity model. And individual step in the activity diagram is called as an action. So it is not a step. It is not a process. It is called as action, individual step. So be clear and concise and precise about your terms and the notation which you use. So what is a model? A model is the blueprint of system to be developed. It is used as a template for developing the proposed system. It is the tool for capturing requirements. If the system has already been developed, you can use it for exploration. As system grows in size and complexity, modeling becomes important because it reduces risk. And also remember the Chinese proverb that a picture is worth 1,000 words. So UML has got its origin by works of three people. In the middle, Ivor Jacobson, on the left, Grady Booch, and on the right, Jim Rumbaugh. Then for making UML models, you can use and utilize various UML modeling tools, including Rational Rose, Argo UML, MS Visio, etc. UML was designed by three people, as I have mentioned, Grady Booch, Jim Rumbaugh, and Ivor Jacobson. Ivor Jacobson is also known as the father of use cases. Initially, UML was a combination of Booch methodology and OMT methodology and OOSE, object-oriented software methods. In 1997, Object Management Group adopted it as a standard for object-oriented analysis and design. So, through UML, we prepare visual models. So, it is a modeling language. It is a language which allows to capture facts and then express these facts. This you can see. So UML has got structure and behavior diagrams. Within structure and behavior diagrams, this is the further breakup: activity diagram, use case diagram, interaction diagram, state machine diagram. Within interaction diagram, sequence, communication, interaction overview, and timing diagram. Then for structure diagrams, there is class diagram, component diagram, object diagram, profile diagram, composite structure diagram, deployment diagram, and package diagram. These are the important UML diagrams for business analysis: use case, activity, state machine, deployment, and class. So now I will take you to the use case diagram, one of the very important diagrams, and this diagram is what we are going to cover in today's case study in MS Visio. So use cases capture the functional requirement of the system. So when you start doing your business analysis activity, you can start preparing the use case diagram. It tells us what the system or subsystem should do. It describes the interaction between various actors and the system. So actor is a word which is what you can call as user plus. So all the users who use the system are actors, and also other non-human users which are interacting with the system are also called as actors. So a use case diagram has got following components. So these are the terminologies. I will explain them and then you will quickly remember them while you will go through the case. Actors, use case, system boundary, relationship, and actor relationship. What is an actor? Actor has got a notation of the stick man, and below the notation is the actor role name is mentioned. How to identify actors? Who uses the system, who installs the system, who starts up the system, what other systems use the system, who gets the information from the system, who provides the information to the system. Use case. Use case are represented by ellipse. Each use case has got a title. Use case is a pattern of behavior for the system. Use cases capture the interaction between actor and the system. Provide an external or user's view of the solution. So what is being done is captured in the use case. How it is being done is not the purview of the use case diagram. It provides user interaction and system response. Use case serves as a specification, also the basis of fundamental testing. How to identify use cases? What goals the actor will attempt to accomplish with the system? What are the primary tasks that the actor wants the system to perform? Will the actor create, store, change, remove or read data in the system? Does the actor need to be informed about certain occurrences such as unavailability of a network or resource? Will the actor perform a system startup or shutdown? Then there is system boundary or subsystem boundary. So rectangle represents the system boundary. So use cases will fall within this. So this is a typical use case diagram. These are the actors. Actors are interacting with the system and their goals are the use cases. Now let us get to the case which I am going to cover. So I will share the case with each of you and then we will prepare a use case diagram, and while I prepare the diagram, I think each of these things will get clarified. So friends, I suggest that each of you go through the text which I have sent to you. Just read it and then we will prepare the use case diagram for this. Case. I will just explain this case to each of you. In fact, I do all the business analysis work on your behalf for the fact that a business analyst has to even prepare this process while he interacts with his clients and while he interacts with his stakeholders. So this is the electricity bill payment process of PVVNL. Electricity subscribers or their representatives collectively called bill payees can make the bill payment by going to the local electricity office and handing over the check or demand draft or cash to the bill receiver. Bill receiver updates the payment in the electricity bill payment system. Alternatively, bill payees can make the payment online through credit card, debit card, net banking or cash card. The online payment is received by DPS Transact system, which is the payment gateway of DPS Bank. Under both the payment methods, after the payment is received, an SMS is sent to the subscriber by SMS software system, which is invoked through electricity bill payment system. Anyone, electricity subscriber or his representative, can make the bill payment if they have district name, book number, connection number, division name of the subscriber. Electricity bill payment software allows its subscriber to view the bill payment and details online. For the same electricity subscriber ID, every electricity subscriber is provided with a subscriber ID and password. Through the subscriber ID and password, a subscriber can view his bills and corresponding payments. To make the online bill payment, a bill payee does not need a subscriber ID and password. Electricity bill payment software is managed by an administrator who can view master reports, total amount outstanding, etc. This allows payments by check for individual subscribers if their check has bounced earlier, and also receive bill payments if a particular bill receiver is absent. So this is the process. For this process, we have to make a use case diagram. Anyone who would like to take up this case should raise his hand, and what I will do, I will now prepare the use case diagram for this particular case. So I do file, new. When I click on new, these featured categories have come up. So though I can see the use case diagram here, if you do not see it, all what you need to do, you need to write use case, and through the search, the use case diagram will come up. Let it complete the search. So I'll click it. So now on your left, what you see here is the template which is showing me various use case notations, and you can see the notations like subsystem, association, dependency, generalization, include, extend, actor, and use case. So we will prepare a use case diagram. So to prepare a use case diagram, let us drag and drop a system here. So I will just rename this system as electricity This is the subsystem. The electricity bill payment software may have many more facilities, and UML is all about conventions, so I will just put it here. Now, first thing is basically to identify use cases and to identify actors. So let us start with identifying the actors for the system. So who are the actors? Actors are those individuals and human and non-human individuals who interact with the software. So can someone share with me his list of actors for this case study? Anyone, you can raise your hand and I will unmute you. Who will identify the actors? Actors are those individuals who interact with the system or subsystem in question. So this is the system or subsystem in question, which is being denoted by this rectangle. And I think we have already given the actors in the case. So subscriber or its representative is one actor. Yeah, you are right. I will agree with you. Bill receiver is also an actor. Yes. So electricity subscriber is an actor and bill receiver is an actor. Who else? Let me drop one actor here. So here you see, here there is slight divergence between the notation which I have shown to you as the stick man, and here a slightly different notation is there. So sometimes software do not have 100% conformance. So beneath the actor role name is written. So I write actor role name, bill receiver. And there is also an actor which is the administrator. Administrator and bill receiver are interacting with the electricity bill payment system. And DPS transaction system is also an actor. Yes, you are right. If it is a third party software. So let us identify the use cases for bill receiver. So I drag and drop a use case here. I identify 3 use cases for him. Payment by check, payment by demand draft, and payment by cash. Not dependency, though it has got the same notation. I will association. payment by so he receives the payment, and you see bill receiver receives the payment. So he who interacts with the system is the one interacting with the use case. So bill payee is not making payment by check. Please understand. I will clarify it here. Bill payee is only handing over his check to the bill receiver over the counter. So it is the bill receiver who is interacting with the use case. And then administrator can do two things. He can view reports and he can disallow check payment. So this is for the administrator. So bill receiver cannot see reports, detailed reports, and he also cannot disallow check payment. And administrator can do all what a bill receiver can do. So this is shown by the dependency here. So this typically tells whatever bill receiver can do can also be done by the administrator, and in addition administrator can also view reports and disallow check status. Then there are, so these three use cases are for payment over the counter. There is also an area for online payment. Online payment, let me go back to the case study. Anyone, electricity subscriber or his representative can make the bill payment if they have the district name, book number, connection number, division number of the subscriber. Electricity bill payment software allows its software to bill and payment details online. For the same, electricity subscriber is provided with subscriber ID and password. To make online bill payment, a bill payee does not need subscriber ID or password. Okay. So we come back here. For the online payment thing, so he is the bill payee. Bill payee can make the online payment. But bill payee cannot see the reports. Reports can only be seen by the subscriber. So bill payee here is the representative of the subscriber. This also I will correct. This is the generalization and specialization relationship. So subscriber is the specialized actor and bill payee is the generalized actor. Bill payee can only make the online bill payment. Subscriber can in addition also view the reports. And whenever the payment is done, just a minute. The online payment is received by DPS Transact system, which is the online payment gateway of the DPS bank. So DPS Transact system is also there. And under both the payment methods, after the payment is received, an SMS is sent to the subscriber by SMS software system, which is invoked through electricity bill payment system. So we also have a SMS software system as an actor. Put it here. So whenever a payment is made, another thing happens, which is the include relationship between these two. So online payment always includes online payment or payment by DD or check always includes sending of SMS. So that is the include relationship. For what? Send SMS. By whom? The SMS software. So SMS software is a non-human actor here. And online payment is being done by the DPS Transact system. So that is yet another non-human actor. So this is how, friends, you capture details or capture specification in a use case diagram. So a use case diagram can tell lot of things. Whatever is part of the scope of the system, those use cases are shown within the rectangle. So this use case diagram has got include relationship. When one use case always includes another use case, that is the send SMS. It has got generalization and specialization relationship between actors. So administrator is a specialized actor for bill receiver. Subscriber is a specialized receiver for bill payee. It has also got non-human actors such as SMS software and DPS transact system. And this is how you make a use case diagram in MS Visio. So two objectives were to be met here: to prepare a use case diagram and also to make it in MS Visio. So this is the end of my lecture here, and I open the session for any kind of question, discussion or comment. So friends, your questions are welcome. You can write it down and raise your hand. So you be ready with your questions. I'll rejoin in a minute. So I have a question from Saji Vijayan. When do we use BPMN and when do we use UML? Can you give and explain with some situation or examples? So I'll just unmute you and we'll try to hear from you. Yeah, please tell me.
In which particular situations or in which particular cases we use BPMN and which cases we use UML? Because both seems to be, both are actually languages which a business analyst uses to communicate to the software team and the vendors.
Yes, you are right. So you see, different when we are preparing something like a detailed software, one diagram or one model or one framework may not be able to capture all the details or all the views. So say for example, when you see this use case diagram, it captures the overall functionality of the system. But let us say if we are to make a detailed process of when check payment is to be disallowed or what reports are to be seen, so then we will have to prepare further diagrams. So BPMN typically covers the workflow or the activities. Use case diagram captures the what is being carried out, and the BPMN diagram will capture how it is being carried out. This is one thing. Second thing is, think of a situation, let us say payment. Think of a use case which is payment from the ATM machine. So use case diagram will only say make payment or withdraw cash. That will be the use case specification. Within withdraw cash, there can be so many scenarios. Cash is not available in the machine, or you do not have your right password, or there is a network failure. So all that is covered in the BPMN diagram, or there is a comparable diagram in UML also, which is known as the activity diagram. So different models or different diagrams capture different aspects. You need to apply each of them. Then it also depends on the preference of your client and the skill set within your company. As a business analyst, you should know it all. Yeah. Anything else? If there is a supplementary question, you can ask.
So can we say that this BPMN is a subset of UML, or is it other way?
Oh, no. BPMN is a different framework or different method. UML is a different framework. So, but both of them to some extent have one objective, that they help us understand existing systems better, or they help us model systems which are to be developed. That is it.
Okay, thank you.
Yeah, thank you. So, friends, this is what is on my agenda right now. I have covered everything, and please feel free to ask any question. I have a question from Rakesh. Has the UML and BPMN language is a suffice for BA to capture the detail? Yes, Rakesh, I would like to hear from you. Would you like to speak? So I think some problem in your mic. So I will repeat his question again. Has the UML and BPMN language suffice to BA to capture the detail? Yes, UML is fairly much detailed compared to BPMN. And together through BPMN and UML, you can capture very high amount of detail for the software to be developed. So friends, allow me to close this lecture. But before that, I have yet another question from Srinivas Murthy. Who are primary actors and who are secondary actors? So primary actors initiate the use case. Secondary actors do not initiate the use case. So in our diagram, I will tell you SMS software is the secondary actor, and bill receiver and bill payee and subscriber are the primary actors. So bill payee has initiated the use case online payment. From that, send SMS use case has been initiated, and SMS software, which is the secondary actor, does not initiate the use case. Similarly, DPS transact system can also be thought of as a secondary actor. So it does not initiate the use case on its own. So primary actors initiate the use case, secondary actors do not initiate the use case. Yeah, Mr. Srinivas Murthy, are you clear?
Yes.
Yeah. Do you need further clarification? So you have written, should the primary actors be to the left? You see, nothing in UML specifies that primary actors be on the left or right, primary and secondary. You can, if you are able to bifurcate them, looks good. If not, doesn't matter. But I do not think UML has got any guidance for keeping guidance or even some kind of tradition to keep secondary actors on the right, because even in our diagram you can see bill payee and subscriber, who are primary actors, they are also shown on the right of the system boundary. So Mr. Srinivas Murthy, if you are having any other questions, please let me know. So friends, thank you for participating in this session, and it is always a pleasure to interact with each of you, and thank you very much, and I am now closing this session.